Okay, so
Yes,
thanks for
okay.
joining us.
Thank you. And yeah, we will start also a little bit with our backgrounds, where we're coming from. So this is us. I am Katrin Hochschuh,
And I'm Adam Donovan.
and together
We are Hochschuh.
and Donovan,
I am matter,
and I'm information,
which is a poetic way of saying I'm hardware.
and I'm software. So together we create robotic installations that focus on creating experiences that are only possible in the here and now. But this hasn't always been the case. I actually originally studied architecture and quickly became interested in parametric design because I made this beautiful pencil sketch, and my professor said, hey, yeah, but you need to get this somehow into your computer to make a structural calculation. And so I sat under the Christmas tree with my mom, who's a programmer, and my uncle, who's a programmer, and they sort of introduced me on the topic, and I became the programming nerd at my university, got a position at the structural chair for computational design, and continued to work, in the digital, programming everything I could imagine, but being trapped in the digital. And so I was wondering how to get out of there, and eventually did another MAS at the ETH for architecture and digital fabrication, where we had like this big industrial robots from like KUKA, ABB, and some UR, smaller ones. And we're sort of trying to follow up this whole process from parametric design, where you could still change everything in sliders, to structural optimization, and then to automatically generating the robot code that would then build this idea. But still, that was then framing this one moment of my simulation in physical reality, and I was again stuck in one state of my fluid models that I enjoyed. I then went a bit more in the direction of the arts by working for a museum of digital art, and did a algorithmic embroidery project for them, and where the user could, or the visitors could interact with an algorithm to then have this co-creation embroidered on a t-shirt or bag to take home. And there I was also the producer of an exhibition where I actually met Adam, because he was exhibiting together with my former professors. And that's how I came to that moment in time where I sort of slowly transformed from an architect to an artist.
Yeah, so my background is actually originally in sculpture in 1994. It's a long time ago. But I've always been interested in the crossing over or the mirroring between psychology, physics, and philosophy and art. So this has embodied itself in a lot of different robotic art projects that somehow take the aspects of physics and changing the way in which we experience. For example, in this case, this is a work called Psychophysics Machines. We have a few different robotic objects. The one on the right is called Curious Tortophone, and the one on the tripod is called Mini Tortophone. These are parametric speakers. I don't know if anybody knows what they are, but these were works I was working on for a number of years that came out of a residency with the Defence Science and Technology Organisation and the Australian Network for Art and Technology in Australia, which was this putting me in Maritime Operations Division Department looking at ultrasound and beamforming. So then I was able to sort of learn from them the physics of how I could focus sound and create beams of sound. So these devices create very narrow beams of sound that if you hold them outside and point them up, you don't hear anything, but if you point them at the head, then you'll hear the sound. And then I create and combine these objects into creating moments that are also only possible in the here and now. and this is sort of to do with more the psychology and philosophical aspect of the human condition, because where I grew up in Australia, I grew up in mining towns, sort of this combination between very wild nature, like 4,000 kilometers from anything, but also very industrialized center with machines rusting in the landscape. And I've always had a sort of a feeling and association with these, even sometimes dreaming of them almost as friends. And I've sort of had this motif going in my work for a long time, wanting to bring people into, I guess, my own memories and my own thoughts and feelings with machines.
Yeah, and then when we met, I was totally fascinated by this directional sound sculptures. And then Adam proposed to me that we could work together because he saw my magnetic field line simulations, and we made this as our first piece together, where the robot is not just the source of this sound, but also shaping the visual landscape. And we started to wonder what we could do together. And then I had been fascinated also by a swarm before in architecture, thinking like a swarm of drones could build some temporary pavilions that then have their decay time programmed into the material. But so we started to also talk about drones, and that's when we sound works. So this is one version before the one that you can see here, because we went through 3 iterations over like 5 years more or less, where we were always enhancing the technology, like making the robots from, let's say, 2.5 hours to now a whole day of runtime by optimizing the way the motors are controlled, and also always observing how the humans are interacting with the robots, and then developing the concept of how they are moving and how we can use movements and behaviors as a mutual language between the robotic swarm and the humans, focusing on the non-anthropomorphic beings.
Decidedly non-anthropomorphic. So is my original work as well, and that's by design, really. And I think that comes from, for me, it comes from Marvin Minsky. I don't know if anyone really know Marvin Minsky, one of the original kind of AI people, now deceased, but he would talk about how there was a separation between the the development of psychology and the development of artificial intelligence, and how that the embodiment in humanoid robots happened very quickly, but there wasn't a lot of background research or what he would say building blocks. So a lot of these robots you could think of, they're decidedly they try to be non-anthropomorphic. So it more lets the motion of what they're doing be, well, what we would say,
be the language.
Be the language rather than this instant association of a face or something. Okay. And that's because we want to deal more with the background concept of what it means to be a young artificial embodied object, if you like.
And we also came across this experimental study of apparent behavior, which Marianne Simmel and Fritz Heider were developing in 1944, which is sort of an alternative idea to the Rorschach ink blot, because sort of this psychological experiments were very well known, and people sort of knew what's the right or wrong answer to those images to not be stamped as a psychopath, to be a bit incorrect here. But so they made this stop motion animation on an overhead projector, and were giving a questionnaire about the apparent behaviors to people who that separately would have to fill in what they were thinking the intention of these simple shapes are. And I mean, I guess each of you can sort of see a certain narrative and intentions and feelings that this little triangle and the circle are having, and a big one. And yeah, we sort of were thinking of, okay, we as humans are hardwired for compassion. We cannot avoid to anthropomorphize and make objects, sort of to give them an understanding that we can sort of feel comfortable with, to classify their behaviors. And so, yeah, we started to work with that.
Yeah, so I think I had a new one yesterday. Somebody said it reminded them of pigeons. But the people will often say this, oh, it's like my cat, or it's like some dogs, or not so much people. But people, we knew from this Fritz Heider and Marianne Simmel that it should work. And I still remember the time where we just had 10 and we switched them on for the first time and ran the simulation, and instantly I saw and felt couples and little groups forming. And later, when we got to about 60 robots at a time, then you could actually see like countries or societies. That's what it had the feeling of, and separations and divisions.
Yes, and so we started to think, how can we sort of combine this human condition that we are all in with our perception of AI, and actually giving AI a body and starting from a very, very simple form.
And I guess I would say, Katrin wouldn't say, but I would say I'm very technocentric. I believe more in sort of technology can be, if it's approached the right way, used for something that is very hopeful and very positive. And I always try and steer away from the narrative that, say, Elon Musk might be saying, you know, oh, we've got to be worrying about AI and things like this, because actually I agree with Catherine Malibu, which is this is a quote from one of her books. And in that book, she is talking about how this fear-mongering of Facebook, Google, all of these things actually is done by them so that they can actually take control of this technology for themselves. And you actually see it happening with Musk right now and his AI. She's also saying that it's the only way to combat this is not to treat AI or robots as the enemy or weapons, but rather to treat them as social and political creatures and include them. So for me, that's really what Empathy Swarm and the research we do and what we try to look at, and how they respond, if we're doing biofeedback with them. And that's really what it's about. It's about inclusion and about, yes, this democratic creation of a collective intelligence, if you like.
Yeah, so we start with a very simple form of AI for the general movement of the swarm algorithm, which is the Boyd algorithm for the simulation of birds or flock of fish, which Craig Reynolds had developed in 1986, I think. And
Flocking, I don't know if anyone knows flocking. Yeah, there's video computer work.
And so we are sort of using this in order to think about how we can use this position in physical space and the movement as a mutual language. And so let's say each of our robots has an interest radius, which is like here in the first one for cohesion, the green circles. And then for each of the robots that are within this interest radius, in each iteration and timestamp, they are calculating the center of mass, and to go towards the center of mass to their next movement step. But at the same time, they have other interests or needs, which is the need to align, to go in the same direction like their neighbors or like the field of view. And so they also getting some part of the direction vector that each of the robots has, and they add them together and get the mean of that and add that also to their next movement path. Then there is maybe the most important one, because otherwise you would just bump into each other all the time, the separation radius, which is sort of like their private sphere, where they decide, okay, I would bump into this one, so I need to go into the other direction. And in order to think about how this could be used in a social mirroring of our society and our personal needs, we are sort of, for this version, playing with the change of this interest radius. So sometimes the robots are very interested in all of the group and rather want to be sociable. But then after some time, they get a feeling of wanting to be alone, let's say, by decreasing their interest radius and increasing their separation radius and moving away from the whole group. And this is something that we as humans can observe in the flock of robots, which does not necessarily give any real information about their feelings or emotions. But for us, we are interpreting it that way. And in our piece, we also sort of equalize the human with the robots by also regarding the human as a circle that has a radius, and that the robots have an interest radius. So sometimes they're interested in the human, sometimes they are not. And they are also changing based on their proximity to them, and also if they are in general in a sociable state or not. And us as humans, we can also increase our radius if we want to have more space, and they are sort of iteratively taken all as the same weight and try to give the space that each wants to the others. So as an example here, reason why they are all like coming together is because they're getting this cohesion, going to the center of the mass very intensely. They are moving in the same direction for the alignment. They come close to the kids in the middle because they are within their interest radius, and the person walking there is standing, thus being much bigger and creating a bigger separation radius where they are trying to give the space. But you can also see that they sort of drawing the boundaries between the different separation radii. And we also were looking at how different distances are valued in our society. It has maybe changed a little bit since COVID, and it's also not the same for all cultures.
Yeah.
But let's say this is like from the 66, so also quite old. But in general, I think I could relate to these distances, but they individually change for everybody. But so it's like 45 centimeters, very intimate. And then there's the personal space, like a radius of 1.2 meters, social space 3.7, 7.6 meters, public space, and then the rest maybe you can't perceive anymore. But so we are also wondering, like, what do these distances that we are feeling towards other people, how close do we actually let technology to ourselves, and also robotic creatures of different sizes, and technology like our smartphone, which is very, very intimate with us, but not having such a physical presence. But so we are also interested in giving this physical body to the robotic life forms. And we did this work.
Cybernetic intimacy, which takes that idea of intimate personal space and is, in this case, it was an outdoor work with 16 hexapod robots and sound beams and synthesis. And we would use face tracking to navigate the robots around the space and project different sounds around in space. And you can see kids love getting up and intimate with the work. So we could go further into detail, but I'm not sure if we have time to talk about that one.
Yeah. So now we're getting a bit closer to like the way of how we can start to think about embodying an algorithm, and also then in the next step maybe thinking about how different ways of executing certain movements give you the feeling of certain emotional states, and how actually this kind of movements also make you feel. So this kind of dialogue between you executing a behavior or a movement in a certain way and how it makes you feel. And on the other hand, what would you think about another being that is executing their movements in a certain way? And there's a lot of different, let's say, theories that try to describe this. For example, in dance theory from Laban movement analysis. But this one I think is very, let's say, easy to understand because it's visualized in a two-dimensional graph and is sort of reducing the complexity for first understanding. So what we have here, there is like a two-axis description of this circumplex model of affect. So one is about the level of activation. So if you're moving quietly or if you're feeling, let's say, quiet or aroused, there's a lot of more subtle emotions that are within these categories. And then on the other level, there's this level of balance from sad to happy. And this model had been applied to movements that can be executed by robots or by humans, which is then going for the speed from slow to fast. So basically, when you're quiet, you're sort of slow, and when you are fast, you're sort of aroused. While if you are sort of sad and combined with being slow, then you are not moving very smooth in a flow, but rather abrupt, or I'm not sure about the English term for that exactly, like hard and abrupt versus soft and flowing, like opposite ends of smoothness. And what we want to do with you now is, first of all, to apply the swarm robot algorithm to us to become a human swarm together, and then at different steps of moving in a certain way to understand how it makes us feel or the other. And we can see how complex we can get with that. But as a first step, I want to invite you to now go outside, and we start with the easiest swarm rule, let's say, which is separation. So basically, you can then go outside, and then
Let's go outside.
I still have this written down here, so let's move once. You have your separation radius that you define with your arms. You started to walk into one direction. Then if there's a wall, you reflect. And if there is another human, you respect their separation radius and yours as well, and you reflect from that human as well. And then in the next step, we can increase and decrease our separation radius based on our need for personal space. And then we can add in like observing what the others are doing to align with them, to cohese with them, and become slower, faster, and more abrupt to create different kind of algorithmically defined emotional states. And afterwards, we can go together to our artwork and see what we perceive after we sort of have experienced these emotions on our own body, and think about the robot's intentions together and answer questions if there's any. So now let's swarm.